Hello, everybody. My name is Connor Brady, happy mathematics tutor, working on a common pre-calculus problem today that I find a lot of kids running into trouble with. It is a quadratic type equation in which we are required to solve for the independent variable. And there are a couple things which at this point in the class, if you are being given this type of problem, that you would have already learned. So that first one is having completed the square, as well as creating a common denominator for two fractions that have variables in them. So those skills are going to be used as I work through the problem here. Allow me to share my screen and pull up my whiteboard, and we'll get started. So, as we said, our leading coefficients are 2 pi, and then our r squared is an indicator that, okay, this is a quadratic type equation. And then our leading coefficient for the b term is 2 pi as well, 2 pi r, and it's equal to a. Now, this equation is used for solving for the radius of a cylinder. And while we're not going to go into too much of the derivation of the formula itself, we're going to be focusing on just solving for r. The whole cylinder, where this formula comes from is a whole other lesson. So we'll just keep right along here by starting off by dividing by 2 pi for each term in our equation. That leaves us with r squared plus r equals a over 2 pi. Okay, now this is the part where completing the square comes into play. And our b term has become 1. So I'm going to write that over here. Just kind of give us a little notation here. B equals 1. So to add a perfect square, we're going to have b over 2 squared. In this case, it's going to be 1 over 2 squared, which is equal to 1/4. So we add 1/4 to both sides of the equation. And that's going to look like this. 1/4 on that side and 1/4 on this side. Okay, next up, it's important for us to combine these fractions. So we're going to multiply by getting a common denominator. So this guy right here, we know by having added that perfect square can be factored into 1 plus or minus b over 2. In this case, b is a positive value, so it's r plus 1 over 2. Close the parenthesis, square it. That's all good. Leave that right there for a bit because we're going to be working on getting that that perfect square. And I actually just realized I need to make an adjustment here. That is not a 2. That is a 4. Okay, going forward, we have to multiply 4 over 4 times a over 2 pi in an effort to make it so that we can add it to that 1/4. And now the thing lacking from the 1/4 is the 2 pi. So we multiply it by 2 pi over 2 pi. And as a reminder, we are not changing the value of either of these fractions. We're just making it so we can get a common denominator. So in 1 second here, we'll see. Now we can rewrite the left side will remain the same as r plus 1/2 squared is equal to 4 times a. We get a 4a. 2 pi times 1 is just plus 2 pi. And then our common denominator here is 2 pi times 4, and that's giving us all over 8 pi. Okay, great. Now I'm going to reduce this, and I'm going to take the square root in one step because I know this video should be as close to being within 5 minutes as possible. So I'm going a little bit quickly here. So I'm taking the square root of the left side and the right side. That's leaving me r plus 1/2 is equal to plus or minus the square root of our reduced side. I'm just dividing a 2 out of each of the terms in the right side of the equation. And then from there, it's pretty obvious. The final step is just subtract the 1/2 to solve for r from both sides of the equation. So r becomes equal to negative 1/2 plus or minus the square root of 2a plus pi all over 4 pi. So let's say you want to find the radius of a cylinder. You now have an equation that will give it for you right there. If you have any questions which have come about as a result of what you see here, or any comments or things which build on this knowledge, feel free to reach out to me on my Wyzant profile. It has been a pleasure giving you guys this demonstration today, and I hope to hear from you guys soon. Have a good one. Bye-bye.